All right, so we're going to go through some probability rules. And I'll be honest right off the bat, this is probably my least favorite part of statistics class. And it's stuff that I find kind of challenging. So if that's true for you as well, I sympathize. For other people, this stuff makes a ton of sense in your brain. And then it's really easy. And so then good for you. So when we're talking about probability, we're going to talk about events. So an event is just something that happens or it doesn't happen. So you flip a coin and you get heads, that's an event. If you draw a card out of a deck and get a red card, that's an event. And coins and cards are two of the most common examples that you'll see in probability problems. But you could also have things like, is it going to snow today? Yes or no? And so, snowing, that would be the event occurring. Not snowing would be the event not occurring. And then we're going to designate the probability of event basically as the long run frequency that event occurs. So that's sort of like the proportion of times the event occurs if you were going to do it many, many times. Probability is always between 0 and 1. If you have a probability of 1, that means that the event is definitely going to happen. And if you have a probability of 0, that means it's definitely not going to happen. And the way that we denote probability is like this. So we'll have P, and then we pronounce the parentheses as of. So P of A, the probability of A happening. And if we need to calculate the probability, we do a fraction. So we have the number of times that A can occur divided by the total number of possible outcomes. So if we're going to flip a coin, getting heads, that would be 1 out of 2 outcomes, heads or tails. And drawing a red card, that's 26 cards out of the 52 cards in the deck. So you can just calculate it as this proportion or just kind of a fraction. So I like to think about these examples in the context of real data. So here's some data from the General Social Survey. You've probably seen this before when I've talked about categorical variables. And this is a two-way table where we're looking at the marital status of someone and then their employer. We probably are going to need to stick those same totals on that we found last time. So I'm just going to quickly add those up and add them onto the table. So you need all of the totals on your table in order to be able to figure things out. But then we could figure out something like the probability of being separated. And that's just going to be the number of times that separated occurred in this data set, 72, out of the total number of possibilities, 2260, and then it's just that proportion. Oh, that would be 0.03, or about a 3% probability. So that's just one event. We could have more than one event, and we use letters for those. So A and B could be 2 events. The probability of A and B, that's the probability that both of those things happen. The probability of A or B, that's the probability that A happens, B happens, or both of them happen together. So it's okay if they both happen. That's the way that we're going to define or for this class. There's other types of or that are exclusive, and we're not going to focus on those. So again, I'm going to stick my totals onto the table. And then I'm going to be able to figure things out like the probability that an American adult is self-employed or divorced. And then I can just figure it out from the table. The bottom of the table is going to be 2260, the total number of events. And then I need to figure out, okay, it's going to be 41 plus 123 plus 41 plus 6 plus 20, and then also this 359. So it's going to be all of these numbers plus 359. So I'm just going to add 231 because that's my total for this column. And then I will also add on a 359 plus 359. So that's 590 out of 2260. Or 0.26, about a 26% chance that someone is self-employed or divorced. And I'll leave the second one as a problem for you to figure out the probability that someone is married and works for someone else. And we can talk about that in synchronous class. We also have a bunch of probability rules. So we just figured some things out just from the table, kind of logicking it through by looking at the numbers, but we also have these formulas. So the additive rule says that the probability of A or B, that's the probability of A plus the probability of B minus the probability of A and B. And so we could figure out the same thing that we did on the last slide. Oh, and let me put my totals back. We could do this same thing, but using the formula. So let's see, the probability of self-emp or divorced, that's going to be the probability of being self-employed plus the probability of being divorced. I'm running out of room here. Let me move that over. And then minus the probability of being self-employed and divorced. So let's see if we can figure those things out. So the probability of being self-employed, that is the 231 out of 2260. The probability of being divorced, that's the 400 out of the same total. And then minus the probability of being self-employed and divorced. That's just the 41. 41 out of 2260. And we can just kind of add and subtract across the top because our denominator is the same. 231 plus 400 minus 41 out of 2260. So that's 590 out of 2260. And I think we'll come up with the same percentage that we did before, 0.26, or about 26%. So that's what I mean about being able to do it just looking at the table and logicking it through, or you could use the rules. And I usually think that it's easier to just look at the table. That's what makes more sense in my brain. But use whichever way that works for you.